Thank you. Welcome to continuous delivery at GitHub. My name is Rob Sanheim. Alternatively titled How We Deploy Up to 50 Times Per Day at GitHub.com without downtime and without going insane. I'm R. Sanheim on the internets. I've worked in software for around 20 years. I started out in Java web development at some fairly standard enterprisey type corporations, and kind of came into the Ruby world via Wise Poignant Guide and the Pickaxe book a while ago, and realized that that was the world I wanted to get into as soon as possible, and joined a startup and learned Rails around version 0.13, I guess it was, something around there, a long time ago, and never looked back. Been very happy. I joined GitHub around 2.5 years ago on the .com team. I've worked on a lot of different things across the whole site. In the Rails, we have a pretty large monolithic Rails app. I started live updates on the site. I've worked on team mentions functionality, done different things with pull requests and issues, and also emails and email verification. Recently helped push through the Rails 3.0 upgrade with the help of a team of around 4 or 5 people, which has finally gone to production just recently, and ready to keep pushing on with that. So what is continuous delivery? Just out of curiosity, how many people here would say that their team or business practices continuous delivery? Okay, that's great. Definitely quite a few people. There's a bunch of different definitions, as it is with a lot of things in software, but it's one of the key points of continuous delivery is it's software that is ready to be deployed at any time. So for us at GitHub, it translates to our master branch should always be deployable at any time. And what this translates to is a continuous flow of value to your customers. And it often should translate into much shorter releases, much shorter feedback loops throughout your software lifecycle, so that you can ship more frequently, do higher quality releases, and have a better time doing it. Why should we care about this? Because continuous delivery, if you are coming from an environment where you don't have that kind of culture in place of continuous delivery, it will be a lot of work. It sounds like a lot of pain. One of the basic reasons is change is ever present and always seems to be only quickening in the software world, particularly in the internet age that we live in. It seems like startups are appearing and disappearing at a ridiculous rate recently, even more so than in the past. Your market, your users, your development tools, the Ruby landscape, all of these things are changing incredibly quickly. How many people had to deal with Heartbleed vulnerability? So this was the open SSL vulnerability that came out of nowhere, I think, for a lot of people, and it would have basically eliminated any of your plans, at least for your ops team, to do any productive work when this happened, and you had to immediately focus on upgrading servers. I wasn't directly in the line of fire at GitHub for this, but I was trying to help where I could, and it was pretty amazing to watch our ops team work with the infrastructure we have in place to allow them to literally start upgrading servers within minutes of hearing about this security vulnerability. Besides all of that, those good reasons, shipping is a lot of fun. I mean, I came into Ruby because it is a lot more fun than Java, a lot more fun than most other software environments I've used, and I find that in the same way, shipping constantly to your customers, to users, is way more fun than working on a release that lasts 6 months or to a year. I think I'm guessing most developers here feel the same way. Even beyond that, your business team, your stakeholders, your business analysts, those people who are kind of trying to drive new features, it's going to be fun and more a better environment for them to be able to say, go try this feature out, and to see it appear live in some form in your production website after a couple days or a week or whatever the case may be, versus waiting months to get feedback on if what they're thinking of building works out. And of course, for your customers, increasingly people expect to have things like bugs, support requests to be be able to tweet at a company online or send in a support email and get a response and see things change rapidly nowadays. And if they don't, they're going to go somewhere else. So continuous delivery ties a lot into releases and cycle time. What does it actually look like when you shorten the release time, the cycle time down? Here's kind of feedback loops in a traditional software world. You can see on the timeline, you have this is going out over 1 year, and there's basically two significant releases. I know I worked on teams early on in my career where it was just this long slog towards building a massive release, and you would ship it out after 6 months to maybe a beta environment or a staging environment, and finally get some feedback. And then you'd collect this massive list of bugs, and then this massive team would steer to work on release 2 and hopefully ship that after a year. So this is kind of an example of how slow the pace is of the traditional software world. Even if you have a good team that's working well in this kind of environment, think of the problem that you have if you get to the end of release 1 after 6 months, and only then do you get feedback from your beta users, your only users, that hey, you're building something that is not useful. You're building something that's polished or well done, but it's not useful. It's not the most valuable thing. You just spent 6 months building something that is not the right thing for your market or for your business. That's really where having cycle times like this in a continuous delivery environment is much more valuable. So the x-axis has changed to just be half a year because normally you're dealing with shorter timelines anyways. And you can see that very first feedback loop for that first release at the left-hand side there. You're shipping something to your team, probably an internal team at the company of developers, maybe QA, maybe early stakeholders that want to try the feature out. They all can start giving you feedback very early in the process. So hopefully if you're not building the right thing, they can tell you really early and your team can divert and go do something else. Ideally, they start giving you feedback on how to polish it, how to enhance the feature, and where to go with to build something amazing. So this is a lot more how releases work at GitHub, especially when we're doing things well and really shipping frequently. So that all sounds great. How do we actually go about it? How does GitHub go about it, or how can other teams go about this? There's a lot that goes into this. I'll go through some of these things kind of quickly because I'm going to assume that things like testing are fairly fundamental at this point in the Ruby world. But I'll still at least touch on them. The strong undercurrent for everything is automation. If you don't have a kind of basic approach of automation throughout your software team and even throughout the culture of the rest of your company, it's going to be pretty much impossible to get to the point where you're really doing continuous delivery. The old idea of when you've done something manually twice, the third time you should automate it. We try to practice that throughout all levels of our development, our operations team. Manual effort will just slow everything down and is incredibly error prone. That leads directly into testing. Testing is kind of the most basic form of verifying correctness. At GitHub, we have our test lines of code. I think recently, actually I'm not sure how recently, but probably within the past year, surpassed the amount of application code. So this is just lines of code count for our test directories. 167 lines of code for tests versus the actual app code, which is 158,000. So we have a lot of tests, and it certainly can be a burden to have that much of a test suite where just things that can break and your build breaks and it can get frustrating. But when you have an app that is at the scale and has the amount of customers and edge cases that something like GitHub has, it's really saved us and also improved quality across the board. Pull requests. How many people are using pull requests every day? Out of curiosity. That's awesome. So we obviously they're very core to the GitHub flow, to the way we work. I think one thing that we do differently, or one thing I've seen that how we use them differently from a lot of other organizations is we open them very early to start the conversation about an idea. I've noticed that if you're working on a branch for, say, 2 weeks, and you wait until like the end of those 2 weeks when everything is very polished and well tested to open the pull request and to get feedback, it's often too long. It's much better to start getting the feedback early for things, or at least to get people's eyes on this pull request so that they can kind of keep up with it and start giving you feedback, or say like, hey, did you see this alternative implementation of this thing you're working on? Or did you consider this? Just before you get too heads down into the code. As an example of this, this is how live updates started at GitHub. It was this pull request. I opened it. The first day I opened it, I submitted the pull request. I CC'd relevant people, like we have some JavaScript experts who know JavaScript much better than me. I CC'd people to consider like the scaling implications of the XHR requests for the pullers and that sort of thing. But when I merged this 3 days later, this was just 60 lines of code. It was pretty alpha quality software. It wasn't ready. It wasn't ready for all of GitHub's general users to be using it. This is what it looked like back then. You can see that little yellow box. That was the full extent of live updates. So it was very rough around the edges. You had to click that blue refresh link to do a hard refresh to pull in updates. So it was actually only half of the live update story, right? You got a notification that there was a new comment in this pull request or issue, but it didn't actually pull it into the DOM. But this was good enough to ship really early and to start getting feedback on. And you may ask, well, how did I ship this after 3 days of work to GitHub.com without annoying a bunch of users or bringing down the site with bad performance? The answer is feature flags. I think they've also been known as feature toggles or just switches. The basic idea is just to allow you to turn on or off features or parts of your site based on certain criteria. The most common criteria at GitHub is if a user is a staff member, or if a user is a member of a certain beta user group or something along those lines. It lets you ship something. It lets you merge your feature to master and get it to production much sooner than if you waited until it was ready for all of your general populace, your Gen Pop users to see it. So the code is trivial. This is basically what it looked like when I shipped the live updates pull request. It was just saying, checking to see if somebody's logged in and if you're a staff member. And then it would be used in the view like that. So the div that was actually wiring up that JavaScript puller to check the server and say, hey, are there new comments? It would be wrapped inside that feature flag so that for anonymous users or just regular users, they would never have live updates firing. It would not impact them at all. So this is the very basics of feature flags. I believe we have usually around 30 to 40 different feature flags in GitHub at any time in different states. And the really nice thing about it is when you go to ship a feature, you just flip the flag to true, and everything that was in the staff-only feature flag code paths now becomes general populace, shipped to everybody. So one thing that I really find valuable about using feature flags in this way is a good way of knowing if you've done all of your due diligence in preparing for a feature is when you go to ship something, your pull request should basically be one-line diff of the feature flag, which previously said, current user is staff or is a member of this team, and that thing goes to true. And everything else that you should have been thinking about for the feature, like scaling and data migrations and polish, that all should have been handled in previous pull requests up to that point. Because by doing that earlier, you were able to get that into master and let it bake and make sure it was of high quality before going to flip this feature flag on. So it's a good sign for me, like when I'm doing code review at GitHub. If somebody goes to ship a feature and then I see a bunch of other things in that pull request, like tweaking SQL queries or changing HTML or CSS, it's a sign to kind of say like, hey, why don't you go do those things in a previous pull request first, in a PR, and ship it first, and then come back and figure out when we can turn this on for everybody. So with continuous delivery, master should always be deployable. I think the inverse of that, which often goes along with continuous delivery, at least from what I've seen, is that long-lived branches are usually a smell. I wouldn't say all the time, but if you're in a continuous delivery environment, you really shouldn't need a lot of long-lived branches, at least for the type of rapid web application development life cycles that I'm talking about. For features, you can figure out a seam to use a feature flag to get that merged into master earlier. For spikes or experimental branches, like they really should be time boxed, and at the end of that time box, say 2 weeks, let's try out this new feature and see how it feels or if the code works or whatever. At the end of that time box, you either say, okay, this is a real feature, let's wrap a feature flag around it and get it into master and make it real, get the code up to snuff, or you decide to kill that spike if if it's not something you're going to continue with. The harder case is infrastructure or architectural changes, things like API changes, gem upgrades, or framework changes like Rails 3, for example. So this is a good example of where our continuous delivery actually fell down for a little while, and took us a while to figure out the right way to work with this. We'd been on a custom fork of Rails 2.3.github, we had called it for a long time, which had worked fine for us, and it had a lot of backports from Rails 3, and various people have tried to upgrade it to Rails 3 even before I joined GitHub, and it just didn't ever work out. So there was just like a graveyard of different Rails 3 branches and attempts. In spring of this year, I took up that branch, which was called Rails 3 Redux. And it's like, all right, I'm going to do this. I can handle this Rails 3 upgrade. We'll build a team around it. And we got a team on it, and people were working on this branch. We were getting the build green and handling all the differences, which when you're talking about 150,000 lines of Rails code, like there's a lot of differences. So progress was slow and steady, but people were getting burnt out on it. At our all-company summit in the summer, we discussed how to actually get over this hump. And we realized like we had been doing this wrong. Like the answer was pretty obvious once we kind of brought it up and talked about it. We needed to kill the Rails 3 Redux branch and get everything into master. We needed to make master able to dual boot Rails 2 and Rails 3. So this was what like bootstrapping looked like for bundling gems. You could set an environment variable of Rails 3 to true to bootstrap in Rails 3, and without that set, you would be in the Rails 2 environment. Our gem file looked like that, where obviously there was a lot more gems than that, but we pulled in Rails 3 for that environment variable, and then like things like will paginate and other things that had version-specific differences, we had to pull in different versions. And then we had version guards like this throughout configuration, which would say, on Rails 3, configure the app like this, and on Rails 2, configure like that. So the process of actually getting master to look like this involved probably hundreds of very small focus pull requests. If you can imagine taking this big branch, Rails 3 Redux, which I think had thousands of lines in the diff, and basically picking off pieces and backporting them into master and saying, like, how do we make this change compatible with version 2 and 3? So by doing that, we were doing it in a very focused, iterative manner, and we were also ensuring that the changes we were making would keep running in Rails 2 because that would get deployed out to production. And we were also verifying that things would really work with Rails 3 because we had a CI build that was exercising Rails 3. And we were getting much closer to really getting real with this. And I think once we finally got everything backported, Rails 3 Redux had nothing in the diff. Then it was just a matter of ramping up Rails 3 across our infrastructure, making sure performance was good and everything was correct and shipping it. So we've seen other huge refactorings at GitHub where you have code paths you want to change that are critical and exercised many thousands of times or millions of times in a day. And if you try to change them and your tests say, oh, the way you're changing this code path is good, your tests may pass, but you might still lack confidence in that code path. Maybe because there could be bad data in your production application that would make things go crazy. Maybe just because there's too many edge cases to reason about, that often is the case with legacy software. So the answer is to use science, or specifically use a Ruby gem that came out of some colleagues' work called Dat Science, which is, it basically lets you run a control path of your code, which would be the legacy code, and a candidate path for your code, and it compares the two, it compares the results. If there are mismatches, it'll publish the results for those mismatches so that you can go and analyze them later. So an example for that may make that a little bit clearer. So this is just kind of a made-up example to hopefully make this clear. So if somebody was trying to change this authorization method, can read a model, so probably pretty critical thing that you don't want to break, right? If you're checking authorization and you make a change and something goes wrong, that could mean that you exposed private data on your site, which would could have really horrible ramifications. So the way this works is the science block executes your control and candidate blocks there. Science will always return the control, so you're not altering production behavior. That's pretty key. It always returns the control path, so you're always going to use the legacy path. But when it decides that science should be enabled, in this case, just doing that enabled check there, it'll run the candidate path, which would be like your new code path that you're refactoring towards. Maybe a new API, maybe uses a new gem, whatever this new code path is you're trying to get into place. So we actually had a huge effort to change a lot of our authorization system that really relied on science throughout the whole effort, and it made it so that we could do this with confidence. Because when you have a lot of legacy data, you probably have bad data from the past. You really need to know that you can catch those mismatches and handle them. So one thing that wires all of this together at GitHub is chat ops. It's kind of the the glue that wires together our continuous delivery infrastructure. So we have Hubot. I think probably a lot of you have heard of it. It's if you maybe are even using it. It's a CoffeeScript bot that runs in chat that lets you do things like deployments. So this is saying do a branch deploy of a branch name myFeature to production. So that branch will get deployed to production. It gets wired together on the back end by some internal tools and Capistrano and that sort of thing that I bet a lot of you are already using. But this is just a command you run in chat that any engineer at GitHub can run to do a deploy of their feature. We have a thing called Branch Lab, which lets you spin up a staff-only environment for doing isolated changes. We can go to specific front-end machines. Like we used this when doing the Rails 3 upgrade, if we wanted to just do an isolated rollout to see performance. And if anything goes wrong, you can roll back to master, which again should always be deployable with deploy/deploy GitHub. And then we have things like CI wired into chat ops and our queue, because during the workday, sometimes we'll have like 5 people who are trying to deploy things out to production, so you just line up in a queue via that. So here's just kind of a snapshot of what that actually looks like in our chat room. You can see at the top Andy up there doing a branch deploy. You can see down at the bottom, the lines in green are successful CI builds. Once the build goes out successfully, at the very bottom is his production deploy that tells you that it goes out. So some of the power here, I think one of the big points here is that this is all transparent. So as a new engineers or less experienced people at GitHub can jump into the room and watch how people are doing deployments or debugging errors or whatever and learn from chat ops. There's no secret hidden away commands to do deployments and that sort of thing. So after deployment, what do we do next? Do we just head out to the bar and grab beers and celebrate after we've merged? We definitely do not do that. We have a lot of feedback tools to check. We have a thing called Haystack that checks exceptions, a lot like Airbrake and Sentry and those types of things. We have a performance dashboard, which is, we actually used to use New Relic a long time ago and eventually just went with an internal tool that does much the similar thing. We have Graphite, which is a really simple instrumentation tool. You can just send arbitrary stats to it from your Rails app, your Ruby app, and it's really useful for that. So if we've verified those things are good and there's not new errors appearing, that type of thing, like are we done yet? And nope, we check Twitter for people mentioning GitHub, for people seeing breakage throughout the site. We have a internal support tool, which I think a lot of people have similar tools or at least have a shared email box, support@mycompany.com, that people can check. So there's a lot of information that you have that you collect feedback from, and then to actually, of course, complete that loop, you need to act on it, which would involve maybe just opening issues or bugs. It might involve rolling back if things are blowing up. It might involve subsequent pull requests to incorporate user feedback and that type of thing. And of course, if something really goes wrong, we try to play like the game of 5 whys, just keep asking why. Like, why was there this huge performance regression? Or why did we have breakage throughout the site? That type of thing. So that's kind of the big picture of how we do continuous delivery at GitHub. There's a lot that goes into that. If you're not in that environment or feel like it's like you could do better, like what are some steps you could do to get started today? I would say like if you don't have a sufficient test suite, start writing tests for new code, or starting at automated tests is kind of a fundamental thing to do. If there's no continuous integration, like no automated build, or if it's flaky and failing a lot, like that is also a sign of just something going wrong, and it's pretty important to fix that and have a repeatable fast enough build for continuous integration. If you don't have a way to ship branches early, like with feature flags or with science or something similar to that, figure out a way to get that stuff in place today so that you can do that. If you don't have like post-deploy feedback, I think those are pretty simple to get started with. Just get Airbrake set up or exceptional or there's a lot of tools out there that can watch for exceptions and at least get a feel for what your current error load is in your application. If you don't have a way to get customer support emails, that's also a great place to start. And if you're on a team that will use asynchronous chat, grab HipChat or Slack or Campfire or whatever, get some metrics going into there, get builds or commits going into there so that you can get feedback from that point. So continuous delivery is awesome. It lets you be more adaptable, more flexible. You can make more money, which is always nice to stay in business, do well in business, and it helps you have a lot more fun doing it. Thank you.